Good afternoon and good evening to all our colleagues around the world. My name's Simon Duval Smith from Automotive Manufacturing Solutions, and I'm delighted to welcome you to this webinar with Nigel Platt, who's Product Line Manager for Cutting and Welding at ABB. Now, I'm sure you're all familiar with the large company that is ABB, but today we're going to focus on the specialities of laser cutting and other use of lasers, for which ABB has considerable expertise. Nigel will give a presentation, and you may register questions throughout in the dialog box on your screens. If you have any technical problems whatsoever, please also just put a question in there as well, and we will respond straight away. We can see that at all times. At the end of the session, at the end of the presentation, Nigel will endeavour to answer your questions, but please ask questions no matter how complex, as he will have time to think about them and respond with specific information because we have your email addresses, etc. You may also wish to point out to your colleagues who are not present perhaps at the moment or in meetings that they can always log on to this later, listen to the whole presentation, and ask questions then at any time. It will remain in the Automotive Manufacturing Solutions archive. So, without any further ado, I'd like to hand over to Nigel Platt. Nigel, the floor is yours.
Thank you, Simon. Welcome to, as Simon says, our colleagues from around the world. My name is Nigel Platt, and as Simon has already said, I'm Global Product Line Manager responsible for the welding and cutting business within ABB. Brief introduction to myself for those of you who don't know me. I've been in ABB for more than 22 years now and have a long history in sales and general management within ABB. I've spent 15 years as automotive sales manager for the UK, and then 7 or 8 years as UK sales and marketing manager, responsible for the both automotive and general industry applications. For the past now 18 months, I have also been globally responsible for the welding business. So today I'm going to try and explore how ABB can help you build some competitive advantage through the use of global standards in laser cutting applications, and I'll primarily focus on cutting today, although as Simon says we do also have significant welding experience today. I will mainly focus on the cutting applications. So this is a brief agenda of the things I'll try and cover today, but as Simon says, if you have any questions, please do type them into the window and we'll try and address those at the end of this presentation. So I'll start with a couple of slides around ABB, but it is only 2 slides just to give an overview to those participants not so familiar with the wider ABB group, and then we'll try and get straight into laser cutting, a little bit of definition and positioning of our offer, the alternatives you have available to you and looking at the options, and then we'll focus in a little bit on why we sincerely believe that robotic laser cutting offers some significant benefits to users over other technologies. We'll look a little bit at where they can be used, and then we'll look at some of the tools and infrastructure that helps give secure solutions to our customers. Finishing with just 1 slide on how we can support you globally, and then there'll be a little bit of contact information and where you can go and get some further information should you need it. So ABB, global engineering company employing just under 150,000 people in about 100 countries, 38 billion revenues, and formed through a merger from Brown Boveri Corporation and ASEA back in 1988. Publicly owned, head office out of Zurich. So where does robotics fit into that portfolio? ABB split across 5 different business areas: power products, power systems, low voltage products, and process automation. So discrete automation is our motion business, of which robotics forms part, and in total that's about a $9 billion business with 29,000 employees. So robotics makes up roughly 4,000 of those employees, and we have robot manufacturing in Europe and Asia, and some small peripheral manufacturing in the US. Sales and service operations in 53 countries, in more than 100 locations. So generally where anybody manufactures, we have a robotics presence there to be able to support their manufacturing operations. ABB Robotics has been in the robot business since late 60s and introduced the world's first commercially available electric robot back in 1974. Since then we have more than 200,000 robots installed worldwide. So a very broad and diverse application experience. We serve all sorts of manufacturing industry, including automotive and their tier suppliers, but of course also a large part of our business is non-automotive, core metals industries, metal fabrication, machine tools, etc. I'm assuming that not too many people listening to this webinar are food industry or pharmaceutical, but we also serve those industries too. So our key market offer really, of course, robots, application equipment, manufacturing cells for all manner of applications, as I've just mentioned, and primarily today we will be focusing on standardized manufacturing cells for cutting applications. So I'll try and walk through these four key pillars really, why robot laser cutting should be interesting. Low investment costs, productivity and quality, flexibility, and I think one of the most important aspects is ease of use and cost efficiency, low cost of ownership, etc. So of course low manufacturing costs, we think that offers a significantly lower investment cost than a traditional 5-axis laser cutter, and I will do some comparisons later on where of course some of those comparisons or compromises may be required, but why we think that that gives you good options for the future. And then we'll look a little bit about the productivity comparable to those of traditional 5-axis machines, and the operational performance in cut, part and shape. Flexibility, very easy to adapt to model changeovers or enhancements to your existing products, adding new features, etc. And I'll show you some software tools that will facilitate that. And again, with the software tools, how in operation they can help you to work in an efficient way. So what is laser cutting? Cutting of materials by directing the output of high-powered lasers, and the power of the laser is of course dependent on the material to be cut and the parameters that you need. So I will talk about some lower power applications too. So what does it do? So then it either melts or it burns or it vaporizes or is blown away with a supplementary jet of air or gas. Can be used in flat sheet applications as well as 3D components, and we see a significant trend in automotive and automotive supplier business with the increased use of lightweight, high-strength steels that often more difficult to process in other ways. And I won't talk too much about plastics today, but there is, of course, many opportunities to use the same technology for cutting plastic parts, trim, etc. So this technology is commonly used for cutting and trimming of hot stamped and hydroformed parts, and of course the electronics and the plastic parts, but I'll focus more today on the hot stamped and hydroformed type applications. Laser processing is often applied where other cutting processes or mechanical cutting processes may be not accurate enough, or other cutting technologies just aren't cost effective for high numbers of variants. We need high flexibility, low volume runs, etc. So a comparison then, what are your options if you do want to be looking at laser cutting? Of course, for flat components you could use a 3-axis flat sheet cutter. It has some advantages, generally lower cost in total, can operate quickly. Cutting speeds, of course, are the same depending on your materials and the size and the power output of the laser. You do have good computer-aided manufacturing programming import options, and generally those solutions offer good shape quality and reasonably high accuracy. Of course, it only handles flat material. So the next step from that would be to look at a traditional 5-axis laser cutter. Again, quite high performance generally, good shape quality, good ability to import CAD data, and are accurate. Some of the compromises for those traditional solutions are, of course, they are expensive, generally use a very large factory footprint where floor space is at a premium. That can be a compromise sometimes, and often you need some quite high specialist training for your operators to be able to live with the technology. And then the third option, which is the one we're here to talk about today, robot laser cutting. Up to 35% lower investment cost typically than a 5-axis cutter, generally a much smaller footprint, and you'll see some standard cell configurations a little bit later in the presentation that support that. Very easily integrated into your existing manufacturing operations, and of course many of the customers that would be interested in this technology are already using robots in many other parts of their manufacturing environment. And on that basis, the robots and the cells are extremely easy to maintain, and all the same tools that you use to maintain your body in white facilities or your sub-assembly systems, including remote service and all of those robot possibilities, are available to you with this technology. Easy to find skilled programmers. There are many people in the market with robot programming experience can very easily be applied to this technology. We have very good path repeatability, and again I'll probe into that a little bit shortly. And all of our standard solutions are built in a modular way from standard product portfolio, making them extremely quick and easy to set up. Customizable, so if you have future needs for, I don't know, bigger parts or different setup, very easily reconfigured. And then all of that is supported with a specific suite of programming tools, both for direct robot programming and simulation and offline programming tools to speed up integration and get you up and running extremely quickly. With the modular concepts, you could of course consider inline applications, taking standard modular cells and integrating them into existing manufacturing lines. There are some disadvantages: marginally less accurate and marginally slower than a 5-axis machine, but in realities of production, the actual throughput and productivity is extremely comparable to the more traditional solutions. So, robotic laser cutting. I've already mentioned, we believe from comparisons that it's typically 35% lower investment cost than a comparable size and performance 5-axis machine, with smaller floor plate space requirements and some possibilities to eliminate some existing operations in your pressing operations. There could be additional features that we could incorporate and therefore take them out of your pressing operations. Very easily integrated into manufacturing systems. Good productivity. As I say, the actual productivity we think is very comparable to that of a 5-axis machine. Even though some of the axis speeds may be slower, the actual cut speeds are very similar because that's process driven rather than machine driven. So it's only the between cut time that you see the performance advantages sometimes from a 5-axis machine. Part and shape dimensions very comparable. As I say, marginally less accurate, but I'll show you some software tools that get us very, very close to that performance all over the working envelope. Good operational efficiencies and the ability to run in an offline environment through some of the tools that I'll show you shortly. Very fast and accurate calibration and tuning, and program generation through the offline tools in an extremely familiar and friendly way to a robot operator. Where do we see the applications? We see primarily automotive, but growing interest and application in non-automotive applications such as aerospace, oil and gas, yellow goods, those types of things. But really it's any three-dimensional contoured surfaces that you want to add additional cut shapes. So it could be replacing, as I say, operations in the pressing. For low volume or high variety options, could be cutting additional holes for particular vehicle variants that are more niche products. Typically upper body parts, A pillars, B pillars, cross car beams, and of course chassis parts. So a typical ABB laser cut cell, as I say, modular solutions built around a range of standards that incorporate these key elements, I would say. Class 1 laser safe enclosures, 6-axis robots, and there are some robots within our range that are specifically better for these applications because of their rigidity and path performance, which I'll expand on a little bit shortly. Of course, the controls, the rest of it is pretty much as in any other piece of robot automation, with the exception of the addition of course, the laser power source and the chillers, if applicable for that particular laser technology, and I'll expand on that again shortly. Yeah, fume extraction and access to the cell as it would be in any other piece of robot automation. So specifically within our range, we sincerely believe that the world's best laser cutting performance robots are two particular products in our range, the IRB 2400 and the IRB 4400. The reason that they are really the best machines for this is their world-class path performance and extremely good rigidity. And again, I'll expand on that on the next slide. So we have a range of fully equipped and pre-engineered cells that cover the majority of the market requirements today. And you see I've listed 4 here. Fixed station, so if you don't need to manipulate the parts, or the other designations, the K, the R and the C are differentiated by the type of workpiece positioner. The next slide expands on that a little bit. And there are 2 specific software tools. There's the robotware cutting, and then there's an additional power pack that supports within RobotStudio, so the offline world, specifically developed to support this application. And of course our global infrastructure gives the ability to service and support you wherever you need to use this technology. So the robots, the IRB 2400 and the IRB 4400, they're the 2 machines specifically in our range with the best combination of path accuracy and arm rigidity that particularly suits this application. Why do they have the best path performance? It's a lot to do with the structure of the machine. With the link arm construction gives a much higher degree of rigidity, and then the motion performance supported by our True Move and our Quick Move software, giving both path accuracy in relation to the speed. So what you program is what you get, basically. So no matter, even if you speed up an existing program, the ABB robot will follow its original path and not start to cut corners or reshape. Steel construction, so as I say, good rigid machine, and the link arm giving good, very good motion stability. And as with the rest of our range, typical 50,000 hours plus mean time between failures, so extremely high availability and reliable robots. So the different cell configurations, of which there are a number. I'll just pick 3 examples here, depending on how you need to manipulate your component or part to be processed. Typically the K style would be longer parts, bigger distances between head and tail stock, so that index is in a Ferris wheel configuration, enabling you to get the robots relatively close to the part, so not compromising the application in those cases where the parts, if it was to the one in the middle of the screen, the R style positioner, of indexes in a rotary way, so of course you need to have the robots out of the way of the radius, the turning radius of the positioner. But it's often suitable for smaller parts. It's a slightly lower cost solution available in similar payloads. So smaller, lighter parts, that would be the right solution. And then the one on the right hand side is effectively an indexing fixed table solution, allowing the operator to be loading one side while the part is being processed on the other in each of these cases I showed here. Very important for the integrity of the system is to be sure that you have an extremely accurate tool center point, so you know exactly where the actual cutting process is being delivered to the part. So we have our bullseye calibration tool, which is an automatically generating the tool center point, eliminating any possibilities of human error. And you can schedule that to recalibrate should there be, you need to replace the head or you've had, I don't know, a clamp has broken and stayed open and you've had a crash condition or anything like that, then you can automatically recalibrate and be back up and running extremely quickly. For reliability and long-term performance of any robot application, not least laser cutting, the cable management and the way that the energy or the signals process, etc., is delivered to the application tool is critical. And again, for the two robots that we talked about earlier, we have a range of standard dress packs to ensure that your fibre optic cables stay in top condition. They're expensive to replace, and it's important not to damage those. And if you need to be delivering cooling or other medium to the laser head, then also that's managed in the appropriate way. Class 1 laser type guarding. Again, modular solutions to suit the needs of the various configurations of solutions that we have within our standard range. They are modular, they are customizable, so should you have an application that takes us outside of the standard, it's very easy to build bespoke solutions from the standard toolkit that we have. Dual wall construction on all four walls, laser safety related windows, and laser safety dual interlock systems, all pre-engineered, all pre-designed, and very easy to get up and running quickly. Range of, we don't manufacture lasers, we work with a number of supplier partners, and typically IPG, Rofin or Trump power sources for the higher power stuff. So that would be like typically 1 to 6 kilowatt applications, but if there are smaller applications, then there are options to use lower power sub 1 kilowatt solutions using the same modular philosophy. Critical part of the process, of course, is getting the laser applied to the product, so the focusing heads or the optics, whatever you want to call them. Typically we work with Precitech and LaserMech, and again all these tools are integrated into our software tools, our RobotStudio tools and our online programming tools to enable extremely quick configuration and get you up and running quickly. So that brings me on to the laser cutting software tools that support the technology. So RobotStudio Cutting Power Pack is an add-in to the standard RobotStudio that offers you very good 3D simulation and gives you the specific tools that you need to create robot cutting programs. So, traditional challenges in robot laser cutting. The traditional challenges really are developing complex parts. So if you have difficult 3D shapes to cut on 3D parts, I should say, then that can be quite difficult to program manually. So we've developed a range of tools within RobotStudio to simplify shape generation, and again I'll show you an example of that shortly. All the interfaces are difficult to tune and calibrate and integrate to other parts of the facility like the laser heads in the past, but we've got a suite of calibration tools within the software solutions that get you very easily up and running. Dedicated laser cutting software functions to improve performance as well, again, which I'll expand on shortly, automatic friction tuning and iterative learning that take away some of the past challenges of tuning the performance. I mean, if you visualize a robot working anywhere in its working envelope, cutting a circle let's say, immediately in front of it in the optimum position. All the parameters within the robot are very different to those cutting, let's say, out on the edge of its working envelope and inverted. So everything's upside down, you're cutting underneath the product, let's say. We have tools within our software that compensate for that, so you get the same performance wherever you are cutting. So what does it give you in the robotware cutting? It gives you a range of predefined user interfaces, so making it very easy to connect to other pieces of equipment. Advanced shape generation tools, easy interfacing, advanced shape tuning with friction compensation, which, as I mentioned earlier, if you're in different parts of the envelope, then that's compensated for automatically. And then the iterative learning control is that we measure the path taken versus path planned, and then if there's a deviation, then the software corrects it on the next cycle. So after it's run a few cycles, it gets better and better at cutting, let's say, a circle. And again, there's an example shortly that I'll show you on that. So the RobotStudio Power Pack gives you all of those same tools in an offline environment, running a real robot controller software within a PC environment. So what you program in the offline world is exactly what you would use in your robot. So there's no translators and no room for loss of anything when you're transferring from the virtual world into the real world. And again, I've mentioned before our standard ABB motion features that give us our world-class motion performance, true move, quick move, and then there are some other tools like wrist move, bullseye, and absolute accuracy as required for the application. Intuitive interfaces. The offline world feels exactly the same as it does on the robot, so a skilled robot programmer, the RobotStudio will feel extremely familiar and take very little training to get up to speed. Adding in the robotware cutting package, extremely quick to get up and running. And you can create your own operator interfaces as well. So if you want specific operator screens or specific parameters you would like the operator to have access to, then that can all be created and given to him on the teach pendant. Automatic shape generation. So there's a library of predefined shapes and cut instructions, holes, slots, rectangles, etc., or some free-form instructions, both linear and circular, so you can create shapes that you need. And then the automatic optimization of those that I've already mentioned. Specific functions to ease the integration of the predefined options for third-party equipment, and with HMIs that support that, with a list of drop-down menus, and I'll show you a screen shortly that will clarify that a little bit. Path following performance. So yeah, well, self-explanatory on the slide really, and I've already mentioned a couple of times. Automatic friction tuning to find the optimum performance with a very user-friendly HMI, and each shape will have its own set of friction compensation values. And again, use the example of cutting a circle or cutting a square in a vertical plane compared with a horizontal plane, an example. Those values would be different, but they're all predefined and very easy to get to. Advanced shape tuning. Again, without going into too much detail, you see the examples on the left without, and examples on the right with very, very significant improvements in performance. So that's a 7mm hole. So it looks a little bit messy on the left-hand side, but much tidier on the right. So what does iterative learning control do for you? So the measuring device is incorporated to record the path shape, and it compares the recorded shape, so of the actual cut hole, to that desired or programmed into the machine, and then it will generate a series of offsets based on those differences. And again, you see some examples here without the iterative learning tuning, maximum deviation of just under 0.4 of a millimetre. With it switched in, then it drops to better than 0.2. And it improves. So the first iteration it goes 0.18, second iteration it goes 0.16, and that's a continuous improvement over time. So RobotStudio, I don't know how many of the participants online are already users of RobotStudio, but very easy to generate cut shape instructions, import the use of your CAD models, and some free-form path generation options. So I just wanted to, and I'm not going to show the whole video, but I wanted to give you a feel for how easy it is to define additional shapes to be cut into a part. So just let this run for 20 or 30 seconds and you see defining the addition of additional holes into our components. So we program where we want the hole to be, set a few parameters, all very intuitive, drop-down menus, etc. And then your program. I won't run the whole video, so I'll skip now towards the end of the video, and you'll see once it's set the parameters. It's available on YouTube, this piece of video, if you want to go and watch it in its entirety, and it takes about 2 or 3 minutes. But we've skipped to now doing some edge processing. But, over 3 minutes, programmed a number of holes, additional slots, additional circles, recorded in real time. So I do urge you to go and search this on YouTube and or on the ABB webpage and watch it in its entirety. And you can see there are a few parameters he sets, but then very quickly we get to a completed component. Now, program ready to run with the additional features that he's just programmed in. And there's the robot running the program. So the whole video takes no more than 3 minutes, so I would urge you to go and take a look. Taking your RobotStudio program, majority of the commissioning can be done offline, and then very quickly up and running. The standard motion features I've already mentioned. I've noticed that I'm running out of time now, so I've not timed my presentation very well, so I apologise for that. So let me just skip through, as I've already mentioned, these tools. So in summary, really, we believe lower capital investment, very high manufacturing flexibility, very easy to program, install and commission, from program generation offline to online installation, extremely quick and seamless process. High precision cutting, and all of the traditional ABB Robotics motion features that many of you will be familiar with, of course, apply to this technology. So what can we do with that? If you have applications, we set up a number of laser labs. So the primary one based in our US operations in Auburn Hills, just outside of Detroit. We established a laser lab now in Shanghai, and currently building one in Spain. We also have a small one in France, but I'll expand on that shortly. There are a range of standard training courses. Just before I get on to that, so what can we do with those laser labs? If you have applications, then please just talk to us and we can talk about whether we can test these for you. Range of standard laser cutting classes, at the moment primarily running out of the US operations, but will in the very short term be available in many of the other application centres that I mentioned earlier. So we have robotics operations in 53 countries, 100 locations that I mentioned earlier. So here's graphically a representation of where we are. Specifically in welding and cutting, we build some knowledge hubs, some application centres. So these today are the welding and cutting application centres, and the ones that primarily focus on laser applications today are Shanghai, Auburn Hills and Barcelona. And the whole portfolio, of course, supported by our comprehensive service and support infrastructure. If you would like to see some more information, there are two key places to go. Have a look at the ABB website and search on robotic laser cutting, and you'll come up with a number of things that are interesting, but also make the same search in YouTube. I'm sorry, there are data sheets to support it which are available from your local representatives, but also good to search just on YouTube. And again, I think the video you see on the top right, the video I used earlier, is also available. Contact information. So I'm Nigel Platt. Got my contact details up here on the left, and these other two guys, Erwin is the Application Centre Manager for the operation in Auburn Hills, and Jorge Ayala is also based with Erwin, but he is one of our application specialists. So if you have specific application requests or knowledge that you need, then bring it to any of us three and we'll get you the answers that you need. So that was me.
Thank you very much indeed, Nigel. Thank you for that. Some fascinating insights there. I think we're going to stimulate quite a few questions. I think the iterative learning is particularly exciting, and I'm pleased to see that we have attendees to this webinar from all over the world. Our friends, our AMS and ABB friends from South America, Mr. Keo Bertolini from Ford Body Shop and Paint Shop, and also Mr. Nicholas Palmqvist, who is the laser expert of Volvo Cars in Sweden. So nice to see you gentlemen on board, and quite a few other people too. We have a couple of questions, one from Min Zhao, and I'm so sorry, Min, I don't know which company you're from. Perhaps you could message us and tell us. And you've asked, can you give us, Nigel, can you give us a number for, Min has said slightly accurate and slower compare with 5-axis cutter. So I think that Min means, can you give us a kind of comparative number? Do you have any metrics? I mean, I personally, and from what you've said, I think the differences are quite small, but do you have any number in mind?
Every application is different, Simon, so it's difficult without seeing the job to put an accurate number on it. But typically, you wouldn't see it. In throughput, you would be within 95% as a average, I was often closer.
Yeah, I was thinking about a 5% difference.
Exactly.
Yeah. Heike Saluma, I'm not sure where you're from, Heike, has asked a couple of questions. Can you tell us about Safe Move, and is that available and is that applicable to this? And also, do you use a safety eye sensor from Rice? Oh, I think Heike must be from Rice Robotics.
We do use Safety Eye in some applications, yes, and Safe Move would not be typically applicable to this technology, of course, because you need the laser power source in a fixed enclosure, laser tight. So Safe Move is a technology where robots can be interacting with humans. So using floor scanners or room scanners, an individual approaches the robot, it will slow down as he gets into the danger area and stop when he gets to a position that could compromise safety. So it can be often used if you want to use an operator to load a tool on a robot, let's say, with an additional component. But this sort of technology needing to be in a light, tight environment, probably not applicable to this in this case.
Yeah, thank you. Yes. Now, Heikki Saluma is from Plantool, Plantoll in Finland. So thank you for those questions. And yeah, I mean, this was leading on to something I was going to ask was, there are still some people who like to program, who like to run with a joystick, right up, you know, guide the robot round and,
Sure.
and go through robot learning in the conventional way. Do you think that your software suite really makes this no longer necessary or desirable?
Well, I do think that, yes. I mean, if people want to program manually, the cutting power pack is an online and an offline tool. So those tools are available on the Teach pendant. But I think in the modern world, your equipment on the shop floor needs to be making parts while you are preparing for the next production. So I think in the modern world, the offline tools much better support, keeping your equipment earning money for you while you're adding new features or reprogramming.
Yeah, no, absolutely, yeah.
Yeah.
No, absolutely. I think it's that the human-machine interface has come along so much that people still do like to guide robots, but as you say, with your modern software suites and simulation technologies and so on, not so applicable. I have a question from Eugenio Pardo. I'm sorry, I don't know which company you're from, sir, but we just answered you that question privately. The presentation will be available and it will be archived, and all attendees to this will receive an email telling you where the archive is so that you can pick it up, and it remains in our comprehensive AMS archives for some time. I have another question here. Can you give us an idea of reliability figures? I mean, where lasers are concerned, Nigel, as you know, for some people they're a little bit like witchcraft, and they're a bit concerned on the reliability of your end of things. Now, we all know ABB robots are as robust as the hills, but do you have any reliability figures for a laser cutting cell in its totality? Any ideas?
Yeah, I mean, as you say, Simon, the overall reliability of a laser cutting cell is no different to any other robotic cell you have on your shop floor. So a lot depends around the peripherals, which is why we standardise and make the dress packs and the way we integrate the third-party equipment into a standardised and modular way, very much intended to improve uptime and availability. So, as I mentioned earlier, robots typically 50,000–60,000 hours mean time between failure, and in a laser cutting cell you would expect to see in excess of 90% availability.
And on maintenance requirements, any specific maintenance requirements in a typical, say, a cell that was doing B-pillars all day long? Are we looking for I mean, maintenance people are hard to find now. I'm sure ABB can help, but what are the kind of typical requirements on, say, running a 3-shift, I don't know, 60 to 100, well, a lot of jobs per hour, you tell me.
Yeah, and again, really, because of the way that we standardise and we modularise the solutions, they're no different to look after than any other robotic facility on your shop floor. So, I mean, robots are very, very low maintenance these days. We have many integrated service tools such as remote service, So I mean, robots now have service instruction indicators in just the same as your car does. So it's not so much a scheduled service requirement these days. It's much more based on the environment and the use that it goes through. So robots will tell you when they need their next service, and I don't know, they'll even tell you remotely that, I don't know, the filters need cleaning in the cabinets and those sorts of things. So this technology is no more difficult to live with on your shop floor than the more traditional solutions. Of course, you need to take much care of your fibre optic cables and those sorts of things, but by making the dress packs in a robust way, then you can minimise the maintenance. So modern laser systems do not take huge maintenance like they used to in the past.
Yeah, right. Thank you. Thank you. And on safety, are there any specific measures? I mean, I think most people in the industry, well, I say most people in the industry should be familiar with laser safety procedures, but where you're going into a company that hasn't used lasers before, the safety aspect, and what backup and training can you help with?
Yeah. Yeah, well, I mean, all the modular standard solutions and cells that we have in the portfolio are all with Class 1 safe enclosures, so including tools like you just talked about, Safe Eye and those sorts of things. So they're all in the standard solutions. So as far as there are some additional laser trainings, safety training that you need, but we run scheduled courses for those, and we can make those available wherever you need them.
Thank you. I certainly had a question myself. I mean, I'm fairly familiar with the challenges of cutting high-strength steels now, but I'm not sure if all of our attendees are. I mean, I don't know if you've got a case study in your head, off the top of your head, but say taking a side beam, a B-pillar made of a very high-strength steel, high boron martensite steel, and how much maintenance of press tools and trimming tools that would take compared to a laser. I mean, some of them can't even really be cut, can they, by conventional trimming?
Yeah, no, I agree, Simon. And I missed the video when I was running through, so I did show at the end. I don't know if people can still see the screen, but
well, run it again for sure. Yes, you can still see the screen.
Yeah, okay. I mean, there's a typical hot stamp, high-strength steel cutting application. So, of course, significantly slower than stamping it, but if it's a tough material with very high maintenance for stamping, then maybe this is a good solution. You can see the cut speeds are quite high.
Yeah, no, absolutely. No, we'll leave that running, please. Yeah, and I've just got a question actually, which is from Alberto Garez. I'm not sure which company you're from, Alberto, but delighted to have you on board, and thank you for the question. He says, I know the best robots are your IRB 2400 and 4400, but is it possible to use 2600 and 4600? And in fact, what I was going to ask is how much can you adapt existing robots to this technology?
Sure. All of the robots in our portfolio can and have been used in these applications. There is some part performance compromise. I would still say that those machines are very good in their part performance, just not quite as good as the parallel arm machines that I mentioned earlier. So it depends on the application. Of course, if you don't need extremely high accuracy, or if you can put up with the shape, your hole size being variable by, I don't know, 0.2, 0.3 of a millimetre, then maybe that's good enough. I don't know. We need to, again, it depends on the job. In some cases, 2600 more than adequate for the job, and significantly better than many of our competitors, of course.
Naturally. Well, you are hoist by your own petard, really, because your robots are such good quality. They outlast humans, I think, these days.
Yeah.
I've got a question from Kore Tokol of Tofas in Turkey. I have two questions, he says. Number one, is there a sheet cutting thickness constraint of robot laser cutting application? Is there a maximum thickness? And also, are there any types of steels that you cannot cut with this application?
Well, the first part of the question, there isn't really. I mean, the limit on the thickness of the material comes down to the size of the laser power source that we're talking about. But typically, in these automotive and general industry applications, cut thicknesses up to maybe 6 millimeter would be not unusual. I guess if you need to do more than that, then we'd need to talk to you and look to see what the right solution for that may be. You can do it with these sort of size lasers, but your cutting speeds will be slower. Second part of the question, I'll be honest, Simon, I can't remember the second part of the question, so go on, tell me again.
Are there any types of steel that you can't use with this application?
That's
I can't think of any.
That's exactly why I couldn't remember it, Simon, because I'm afraid I don't know the answer to that one. I'll have to come back to you.
I really cannot imagine there being anything that you can't cut. I mean, because as you can cut carbon fibre and composites so accurately and
exactly.
And excellent, better than you can with any other, even water jet cutting.
Yeah, there is a development project going on in the UK, and one of the university partners we have right now that will be installing the highest powered robotic laser system in Europe shortly. And that's for cutting some titanium type parts, so in an aerospace application. So there are many obscure materials and experience around.
Yes, thank you. Alberto Gales is from Spain, from Valencia in Spain, so we can get a clue as to which car manufacturer perhaps he works for. Yeah, I wanted to ask, it's a major concern of a lot of OEMs and tier supplier users of your and other people's manufacturing equipment, is the localization of spare parts, and do they need to keep a big stock of spares themselves and spend 4 or 5% of their total cost on buying spare parts? Now, you're integrating, working with laser head makers, with the laser makers. Are you going to be, it's a contentious question, but are you going to hold lots of spares, or how is it going to work?
No, we don't retain spares for the laser manufacturer. I think that's really a case of sitting with the client or the potential client and agreeing what the most appropriate support infrastructure is for them. And I mean, globally, ABB ship spares all over the world in next day delivery. So there is, in the modern world, really no reason to hold very large stocks of anything from a robot perspective. So I really don't see it should be that different for the major laser power source suppliers that all have global footprints, which is why we work with them.
Yeah, and given
that we can help with that. That's not an issue really.
Yeah. It's sometimes at AMS India and AMS China and AMS South America we do get these observations, particularly in China, that spare parts are just not local enough. But I mean, if they're not local enough with ABB, they can't be with anybody, because I think you have one of the largest global footprints. Yeah.
And under the right conditions, we can agree consignment holdings and all of those support things. So we can always find a solution for that.
Thank you. Good. Thank you. We haven't talked at all about direct versus remote lasers here. You're talking here really only about direct, not by mirror laser and so on. Are there applications where you can get to more awkward places using an indirect laser technology?
There are, but not in the standard solutions I wanted to talk about today. So again, if you've got those issues with your manufacturing facilities, talk to your local representatives, and that would be a more bespoke solution, I would say.
Thank you very much. Yeah, the only other thing I was going to ask about was carbon fibre and composite, and I know you didn't want to touch on that too much, but I mean, maybe if you can just tell us, how laser is so much better for carbon fibre. There isn't another solution for a lot of composites and modern and carbon fibre and modern composite materials, is there?
No, there isn't, and as you say, this technology can be applied to all sorts of materials. So again, I would just urge you to discuss it, those applications and those materials with us, and we can run tests in the laser labs in the various locations around the world if appropriate. So not a problem.
Thank you. So on the kind of global coverage, your laser labs are in many locations where you can invite a client in and take their piece of work and set it up and show them how it's going to work. Is that how you would present it to a possible client?
Yeah, we don't intend to have laser labs in every country because, of course, it's a bit specialist and quite expensive to own and and run at every location. So at the moment, we established our first laser lab in the US operation. We're up and running in China very shortly, and we're just finishing a demo facility in Spain right now. There will be others, of course, but at the moment they're the primary 3 locations.
Thank you. Yeah, and I'm not sure if all the attendees are aware that ABB has really put a lot of resources and a lot of concentration into China, having your centre in Shanghai there, which I know I visited, and it's very impressive.
That's exactly where the laser lab is, in that facility you've been to, Simon.
Oh, wonderful. Yeah, wonderful. Right. I don't see any more questions, Nigel. Was there anything you would like to round off with?
No, only to thank everybody for giving up an hour of their time to listen to me, and for those that celebrate Christmas, have a very good Christmas, and for those that don't, a happy and prosperous New Year.
Very well put, Nigel. So thank you very much indeed, Nigel Platt from ABB, and thank you to all our listeners and attendees, and again do recommend to your colleagues that they can pick this up from the email that we will send you as an attendee. You will also be able to find it on our AMS website, and you will have a link to the archive where you can pick this up and previous ABB presentations. And yes, I'd like to thank ABB from the AMS team. Thank you for your support through the year, and it's been always great working with you, and to wish all of our readers and attendees a very happy holiday, and as you say, a prosperous new year. Thank you, Nigel, and see you next year.
Thank you very much, Simon. It's been a pleasure. Talk to you soon.
Thank you. Cheers. Cheers. Bye.
Bye-bye.